Let us understand details about different types of constraints used in RDBMS databases. These are the most commonly used ones. There might be few others, but we typically use these ones in most of the cases. We have not null constraint, where a column value cannot be a null. We can have check constraint, where a column value will be compared against those values that are defined as part of the check constraint. Other values cannot be there. We can have a unique constraint, where a column value have to be unique. The same value cannot be repeated more than once. Example, email ID. Typically in users table, we will have email IDs as unique because we cannot have two users with the same email ID. Then comes primary key. Typically these are nothing but unique as well as not null. And there can be only one primary key. We'll get into the details about primary key as well as unique at a later point in time when we talk about comparison between the two. And then foreign key, where we will define from one table to another table. I will actually explain with an example at a later point in time. All constraints can be added while creating the table or on pre-created tables using alter table command. Typically we define not null check constraints while creating the tables. However, we can also specify not null constraints as well as check constraints to the columns while adding columns using alter table, or we can also say alter table alter column command, and we should be able to enforce not null or check constraints on the existing columns. We have seen some examples as part of the previous topic. We will see more as part of the next topic, where I will be demonstrating few of the aspects about constraints hands-on. Foreign key constraints are created after the tables are created. It is primarily used to define relationship between two tables. However, keep in mind that even while creating the tables, especially while creating the second table, you can have a foreign key defined to the first table, but it is not a practice that is followed. In many cases, we first have create table commands which will take care of creating all the tables, and then we have alter table commands which will actually enforce foreign key constraints between the tables. When it comes to foreign key, the example is users and user login details. We can have one user log in multiple times in his lifetime, and hence we have one-to-many relationship between users and user login details. In this case, users will be the parent table and user login details will be the child table. The common key between them is nothing but user ID. We'll define user ID as primary key in users, and then we'll have a foreign key from user login details user ID to users user ID. So that's how we typically think and implement foreign key constraints between two tables. Primary key and unique constraints might be added as part of create table statements or alter table statements. Both are commonly used practices. Let us compare and contrast primary key and unique constraints. There can be only one primary key in a table, whereas there can be any number of unique constraints. Unique columns can have null values unless not null is also enforced. So you can have a column which is defined as unique, but on top of having a unique value whenever value present, there can be null value repeated many times. The uniqueness will not be enforced on the null values. In case of primary key, both uniqueness as well as not null are strictly enforced. In other words, a primary key column cannot be null, whereas a unique column can be null unless not null is enforced on unique column. Foreign key from a child table can be defined against primary key column or unique column. Typically, primary key columns are surrogate keys which are supported by sequence. Even though at times we might have a primary key which have some business value, many times the primary key columns will be surrogate keys. If you take the example of email ID, it can act as primary key when it comes to the tables like users. However, if we define email ID itself as a primary key, all the child tables also need to have the email IDs, and it can cause some issues with respect to the security. Also, from the performance perspective, enforcing the constraints using integers is much more robust and scalable compared to enforcing the constraints using non-integer values, especially strings with respect to email IDs. For both performance as well as security reasons, we typically have an additional column when it comes to the primary key, which doesn't have any business value in it, which is typically populated using sequence. It will be easier for us to generate sequence numbers and enforce uniqueness within the primary key constraints. That's why we actually map a sequence to the primary key columns. Primary key or unique can be composite. It means there can be more than one column to define primary key or unique constraint. It need not be the case that the primary key or unique have only one column always. There can be more than one columns when we want to enforce the primary key constraint or unique constraint. Typically, most of the composite keys are unique, not primary keys. Let's take an example of LMS and understand how the relationships will be defined by taking three tables: users, courses, and students. Users contains columns such as user ID, user email ID, user first name, etc. It typically have all the information about users who signed up for the LMS platform. It can be our website, or it can be Udemy, or it can be anything. There will be columns such as email ID, first name, etc. as part of the users table. We can enforce primary key constraint on user ID, and unique constraint can be enforced on user email ID because emails are typically not repeated for multiple users. For that reason, the unique constraint will be enforced on user email ID. When it comes to courses, it contains columns such as course ID, which is again a primary key, course name, course price, etc. Now, when it comes to students, students is a bridge table between users and courses. There is a many-to-many relationship between users and courses. One user can enroll for multiple courses, and one course can be enrolled by multiple students or multiple users. That's why we have many-to-many relationship between users and courses. To bridge these two, we have a table called as students. A student is the one who actually enrolled for a course. Unless and until a user enrolled for a course, he will not be treated as a student. And also, one course can be enrolled by multiple users, which means one course can have as many students as we can. And hence, we have many-to-many relationship between users and courses. It contains fields such as student ID, which is nothing but a primary key, user ID, course ID, amount paid, enrolled date, etc. Primary key constraint will be enforced on student ID, which is a surrogate key, which is nothing but a sequence generated number. A foreign key constraint can be enforced on student's user ID against user's user ID. Another foreign key constraint can be enforced on student's course ID against course's course ID. We have two foreign key constraints in students table, one to users and other one to courses. Also, as one student cannot enroll for the same course multiple times, we can have a unique constraint between user ID and course ID. That is what I'm highlighting here. We can have unique constraint enforced on students.user_id and students.course_id. It will be a composite key as there are more than one columns in it. So this is how we can actually think through the problem, identify the tables, then the relationships. Once the tables are identified and relationships are identified, we can enforce the required constraints on desired fields such as primary key constraints, unique constraints, as well as foreign key constraints.